You're bad at estimating, especially if you're a male. Men are terrible at assuming they know something that they don't. Estimating isn't about guessing, it's about using something that you know to figure out something that you don't. So, let's have a look at this question. Pause it now if you want to have a go yourself. Which of these is a reasonable estimate? Well, we'll start with the spring constant. The spring constant of an elastic band is 0.5 newtons per meter. Stop. I can see you're trying to guess the answer. We're going to rely on what we already know. The spring constant is in newtons per meter, i.e. the amount of force it takes to stretch something by a certain amount. So it says it takes 0.5 newtons to stretch an elastic band 1 meter. Well, you know what a newton feels like. It's one of those circular weights that you get in the classroom. They weigh about 100 grams, and that's the force of 1 newton. So if we take half of that and tie it to an elastic band, would it stretch 1 meter? No, of course not, maybe 5 centimeters. So we can eliminate that answer. Well, what about the kinetic energy of an Olympic athlete? Well, the kinetic energy formula is half mv squared. It's in your formula booklet. All we need then is the mass and velocity, and you should know those roughly. If you're rapid like me, you can run the 100 meter in about 10 seconds, and we've all seen Usain Bolt do the same. So that gives us a velocity of 10 meters per second. And we can estimate mass based on our own mass. You're expected to know the mass of a human because you are a human. It's going to be somewhere between 40 and 100 kilograms. I'm going to go slap bang in the middle and go for 70. That will give us a kinetic energy of about 3,500 joules, which is much bigger than 200. So we can eliminate B. Let's look at C. Now, you can't guess the mass of an atom, but you don't need to. Our formula booklet tells us the atomic mass unit, which is about 1.6 times 10 to the negative 27 kilograms. You need to know the mass number of carbon-12 because it's tied to the definition of the atomic mass unit. So all we have to do is times that by 12, and we'll see that that's nowhere near 3 micrograms. So finally, we get to the wavelength of blue light, and this one is actually the easiest one because we don't have to do much guessing at all. Everything we need is in our formula booklet. If you look at the booklet, you'll find the spectrum of the entire electromagnetic radiation. And it tells you roughly what all the wavelengths are. So let's have a look at visible light down at the end of the lower wavelengths, and we can see blue light would probably be somewhere around about 500 nanometers. Now I've been going on now for almost 3 minutes, and for a 1 mark multiple choice question, that's too long. And that's because we didn't think about this question tactically. We answered all the hard parts first without going for the easy parts and working from there. We don't want to answer any hard questions if we don't have to. If you're studying IB Physics, give me a follow and I'll help you understand your exam and how to test better.